Okay, we're going to start on Unit 6 now for college prep, and this is topic number 1. We're trying to find the domain of the function. First, before we get started here, we got to understand what domain means. Domain is all of the possible x values that work in an equation. So if this is the function or the equation that we have, we're looking at everything that works possibly for x. The only thing that could be a problem here is that we have a radical and we know that we can't take the square root of a negative number. That's basically what the entire unit is about radicals. So we have to realize that we can't take the square root of a negative number. And so basically that's our only thing that's going to stop us here. So we got to figure out how we can write this out in interval notation, basically saying that we can't have any negative numbers under there. So this -6, it's basically useless. Now I have another example over here that we're going to go through in just a second. And that one has the -6 or the -6 inside the radical, and that's going to change things up when we do that one. But let's just start here. The -6, I don't really care about. That's just subtracting it at the end. We could subtract 6 from anything. So we really only care about what's under the radical. In this case, it's x. So we're going to take what's under the radical, that x, and we're going to say it has to be greater than or equal to 0. That's the only way. Whatever's under the radical has to be bigger than 0. So now I'm going to write this in interval notation. We know interval notation from first semester that anything greater than 0 would be 0 to infinity. Since there's an equal sign, I have to do a closed bracket, and I'll do a parenthesis around the infinity symbol. On this second example, we have x minus 6 under the radical. So I'm going to have to put all of that, the x minus 6, all of that is going to have to be greater than 0. Because whatever that turns out to be, whatever this highlighted part, I'm about to highlight it, whatever this is, we just know that it has to be greater than 0 to work. So then I could add 6 to both sides. So I get x is greater than or equal to positive 6. And if I wrote that in interval notation, it would be 6 would be the small end, and then it would go to infinity. So basically anything greater than or equal to 6 would make this equation work. Topic number 2. On topic number 2, I can see that I've got just this under the radical, so it's very similar to topic number 1. I am going to set what I highlighted there greater than or equal to 0. It's the same idea as the first one. It just kind of looks a little different now. We've got a negative under there, and you might think initially like, oh, we can't do this. It's got a negative. But if we divide both sides by -1, remember, if we're dividing, we're going to have to flip our sign around. Same thing with multiplying, but it does the same thing when we're dividing or multiplying by -1. But we'll be left with x is less than or equal to -1. I flip my sign around there. So this is what I've got to put in interval notation now. If I put that in interval notation, -1 is actually going to be the top end of my interval notation because we want x to be less than or equal to -1. And then negative infinity would be the small side of my interval notation. And we're done with topic 2. Let's say that this was changed up a little bit. So let's say that we had -x plus 2 all under there. You'd set it up the same way. We just have to do -x plus 2 is greater than or equal to 0 because whatever's under the radical has to be greater than 0. And then you would just solve for x there. So you'd have to subtract 2 from both sides, multiply or divide by -1. Flip your sign around when you do that, and you'll have your interval notation. Topic number 3. On topic number 3 here, it wants us to actually graph the function. So it's set up the same way. If I set this up, I think this is actually the same one as the first question. Oh, that one was -6. This one's +6. That's okay. Anyway, when I set this up, by the way, I have the answer already on here. So we're going to look at that in a second. So that's not a part of the question. That's a part of the answer. Or that is the answer. But I'll explain that in just a second. So if I'm graphing this function, I need a table first. So I need to think about some things that would make this be allowed? What's the smallest number that you can think of that would work under that radical? Well, I know 0 is the smallest number that works under that radical. And if it was a 0, then we would be at 6. Let's assume that it was a 1. The square root of 1 is 1, plus 6 would be 7. If I plugged in I'm going to go for a number that's a perfect square. So if I plugged in a 4, for example, the square root of 4 is 2. 2 plus 6 is 8. If I plugged in a 9, oops, I didn't mean to do that. No, I did. If I plug in a 9, the square root of 9 is 3. If I add 6 to 3, that is 9. And you can see that that's kind of what they have listed here. Those are the exact points that you can see on this graph. So those are the ones you'd have to enter, and then you just push the graph a function button on Alex, and it should do the work for you. For the other one, if I'm setting up my table, this is a little bit trickier to figure out what number we can start with. But obviously, we got to figure out a way to get to 0, because 0 is the lowest number that we allow inside a radical. So that would mean -6 would work, and we would get a 0 out if we plug that in, because -6 plus 6 is 0. And we take the square root of that, and we get 0, obviously. Let's try another number here. So I got to think about numbers now that I can actually take the square root of. So 1 is a number I can take the square root of. So what would I plug in to get a 1? I guess -5. So if I plug in a -5, I get 1 under the radical. If I take the square root of it, the square root of 1 is 1. What's another number I can plug in? Let's see, how could I get to 4? With 4, I'd have to plug in a -2. If I plug in a -2, that gives me +4. If I take the square root of +4, I get 2. Then I'll do one more, getting to 9 now. What would make this equal 9? Well, a +3 would make that equal 9. If I plugged in a 3, I'd get 9, and then I'd take the square root of 9, I'd get 3. So these are the numbers that I would plug in on Alex. Moving on to topic number 4. Topic number 4 is pretty quick and easy. I just have to rewrite this. And the way that we do this is the number that is on the bottom is the number that goes out front of the radical. So when I make this radical, x is going to be that number inside. 2 is its exponent, so that's coming from here. And the number that's on the bottom goes out front. And that's it. So this would be something that I definitely put down in my notes, because it's basically a template for all of those problems that have fractions on them. Topic number 5, it's asking you to evaluate these. So basically, the 343, we can think about this problem as the cubed root of 343. And honestly, if you know how to type it in with the cubed root on the calculator, I would do it that way. Otherwise, if you don't know how to, you can just type this in. I really don't need to explain this too much more, because these problems, if it was me taking the test, I would just type them into my calculator. But it is good to know that this, like 625 to the 1/4 power, is the same thing as the 4th root of 625. That's pretty important to understand too. Topic number 6. Okay, so this is kind of tricky. So for the first one here, if I were to rewrite this, we would have a -243 under there, and then the 1 would technically go there, but I'm not going to write it there because it's not necessary, but the 5 would go out front. Now it wants the 5th root of -243. And so you'd have to type that into a calculator to figure out what that is. I don't have one on me right now, so I don't actually know what that is. But I do know right now that that is going to work. It's going to be a real number, because you can take the 5th root of a negative number. You can actually take odd roots of negative numbers. Any even root, you can't take the negative, or you can't do it. If you're confused by this, I would suggest you just type this into a calculator, and it'll tell you if you can do it or not. It'll say not real, or it'll give you an answer. So it's that simple just to kind of type it into a calculator. So this one I know will work because it's got an odd root. This one will not work because it's got an even root, that 4. It's kind of like you can't square root a negative. Anything to the even power, you can't take the square root of a negative, or whatever. You can't take the radical of a negative number. Topic number 7, it wants me to simplify 4 to the 5 halves power. So 4 to the 5 halves power. If I were to rewrite this, this would be the same thing as 4 under the radical. The 5 would be its exponent, and we'd be taking the square root of it, basically. That 2 out front is the same thing as the square root. Okay, so I think we can probably just do this on a calculator as well. I do not have a calculator right now. I'm going to just pause for a second. I'm going to go grab one just so that we can do this. Okay, so if I took 4 to the 5th power, I get 1024. If I take the square root of that number, I get 32. So hopefully you can type that into your calculator. It's good to rewrite it like this for what's coming up in the future. So make sure you have that written down too, and you're not just typing it in. Number 8. Okay, let's see. We have 125 to the negative 2/3 power. So remember from first semester, when we have negative exponents, what we want to do here is we want to put them on the bottom of our fraction and make those exponents positive. So this will be 125 to the positive 2/3 power if I put it under the 1. Now if I change that around a little bit, I'll have 1 over a radical with 125. This 2 will be squaring the 125, and the 3 will be cube rooting it. And so that is how you would write it if you changed its form around. But again, this has been true for all of them. You could just take this and type it into a calculator if you really wanted to. So 125, I'm just going to type it in my calculator. 125 to the negative 2 over 3 equals 1/25. So basically all this stuff down here would end up being 25 if you took the square or the cubed root of 125 squared. For the other one, we have 1/8 to the 4/3 power. So this is kind of interesting because that 4/3 will go to everything inside. So it'll go to the top base and the bottom base. 1 to the anything is 1. 1 to any power is 1. Except for, for every power. So really, the 1 to the negative 4/3 power is just 1. We'll change that in just a second. But then we have 8 to the negative 4/3 power. My next step would be just make that a 1 over 8 to the 4/3 power. Negative 4/3. And then my last step would be to change that 8 and flip it to the top. So I'd have 8 to the regular 4/3 power. Now if I change that into a radical, I would have the radical 8. The 4 would go here, the 3 would go there, and I would need, I'd need to use a calculator probably to figure that out. So let's do that. 8 to the 4th power is 4096. And then I'm going to take the cubed root of that. Let's see. I don't even know where that button is on the calculator right now. I'm looking for it. The cubed root button. See the square root button? Oh, it's right there. It's above the caret symbol. It's above the symbol that looks like that. It's got a little N there. So control caret, and we can do 3, and then 8 to the fourth power. I got 16 off of that. Okay, where are we at? Topic number 9. Looking to see here where I should go. I might wait for topic number 9 until next time. So, all right, that's it. Thank you for watching.